Hello, my name is Florentin Smarandache, professor of mathematics at the University of New Mexico, United States. And thank you for inviting me to have a presentation about new types of soft sets: hypersoft set, indeterminate soft set, indeterminate hypersoft set, super hypersoft set, and three soft set, which are introduced in the last 2 years, uh, following the soft set. So the soft set was introduced in 1999 by the researchers Molotov, and further on, I introduced the hyper soft set in 2018, indeterminate soft set in 2022, indeterminate hyper soft set in 2022, three soft set in 2022, and then super hyper soft set I introduced this year, 2024. So you know the classical definition of the subset. So subset is defined as a pair FU, where F is a function defined from a set of attributes to the power set of the universe of discourse. And then a real example, if we have the universe of discourse formed by four people, Alan, George, Mary, and Richard, and then a subset formed by Helen, Mary, and Richard, which are included in U. And let's consider the attribute size, for example, small, medium, and tall. The function f defined from A1 to P of U is a subset as defined by Molotov. For example, f of tall equals Helen, Mary, which means both of them are tall. Further on, I extended the subset to indeterminate subset. So indeterminacy is the third part in a nutrosophic set, as you know. Besides truth and falsehood, or membership and non-membership, there is the indeterminacy, which is in between the opposites, truth and falsehood. And we consider that an indeterminate subset is a subset as defined by Molotov, but which has some indeterminacy with respect to either the two functions, A sets of attributes, or P of H, which is the power set. And some little examples. So I extended this one. And the real example of indeterminate subset. Assume we have a town that has many houses. Now we have indeterminacy, for example, with respect to the set of attributes. If you ask the source, for example, what are all colors of the houses? The source may respond, I know for sure that there are houses of colors red, yellow, and blue, but I do not know if there are houses of other colors. So in our everyday life, we don't have complete information, so we have missing information. So here we are not sure about the all colors. So the set of attributes is not clearly known. Or the set of houses is not clearly known. For example, if you ask the source how many houses are in a town, the source may respond, I never counted them, but I estimate the number may be between 100 and 120 houses. Therefore, H from the soft set is not well defined. We have also indeterminacy with respect to the function. For example, asking what houses have the red color in the town, and then the source may respond, I'm not sure, I think the house is H1 or H2. So not clear if it's f of red is H1 or H2, house number 1 or house number 2. So that's the indeterminacy. Another type of indeterminacy, for example, having what houses are yellow, and the source may say, I do not know, but the only thing I know is that the house H5 is not yellow because I just visited it. So f of yellow is not H1. So not H1 may mean the other house is not H5. Maybe the other house is H1, H2, whatever, except H5. So we have some uncertain answer. Another questions, for example, relating to indeterminacy, what houses are blue? And then somebody says either H8 or H9. Again, it's not clear which one of them it's true. In 2018, I extended the subset to the hyper subset in a sense that the function f is defined from Cartesian product of sets of attributes, A1, A2, and so on, AN. So we have F defined from this one to P of U. As an example, if we consider the previous example, U is equal the set the set of following persons, Ellen, George, Mary, Richard, and M, a subset of it, Ellen, Mary, Richard, and the attribute A1 may be size, H2 color, H3 gender, H4 nationality. So we have 4 different types of attributes, and each attribute has the corresponding values. For example, size may be small, medium, tall, color may be white, yellow, red, black, and gender may be male or female, nationality, American, French, Spanish, Italian, Chinese. So the function defined on the Cartesian product of A1 times A2 times A3 times A4 with value in P of U may be in the following way. Let's see an example. F of tall, white, female, Italian is equal to Ellen, Mary, which means that these two persons, two elements, Ellen and Mary, are both tall, white, female, and Italian. This is an extension of the soft set. Now, indeterminate hyper soft set. Indeterminate hyper soft set is the soft set, the hyper soft set which has some indeterminacy. Again, the indeterminacy were not clear known things or things that are alternating. So we are not sure which one of them occur. We have an indeterminate hyper subset. For example, we may have indeterminacy with respect to the sets of attributes, A1, A2, AN. Or we may have indeterminacy with respect to the sets of H or P of H. Or we may have indeterminacy with respect to the function. So we have the function f of A1, A2, AN equals M, such that at least one of A1, A2, AN is indeterminate. Indeterminate meaning unclear, uncertain, or conflicting information, or not unique, or completely unknown. Example of indeterminate hyper subset. Again, we have a town of many houses, and we have, let's say, indeterminacy with respect to the sets of attributes. And in the same way, what are the colors and sizes of the houses? And the source may say, or information that we receive, the expert, in order to evaluate them, there are houses of color red, yellow, and blue, but I'm not sure if there are houses of other colors. Also, about the size, we saw many houses that are small, but I do not remember to have seen big houses. Indeterminacy with respect to the set of houses. How many houses in a town? The same thing. May say, I don't know exactly the numbers, there are many, we didn't count them, we expect between 100 and 120. Indeterminacy with respect to the function, what houses are red color and big size in a town? Again, not sure. I think the house is H1 or H2. So we have F of red and big. So we have two attributes is equal to H1 or H2. So again, not clear, either H1 or H2 or both H1 or H2. So is the disjunction between the houses, or what houses are yellow and small? Again, not sure, but we know H5 is neither yellow nor small. So in this case, when we say F of yellow small is equal not H5, meaning all the others. So we know very little information. H5 doesn't verify it, but about the others, we don't know if they are or are not. Another question, what houses are blue and big? Again, it said for sure either H8 or H9. So the answer, the correct answer may be either H8 or H9. That's it. So we have a little more information, but we don't know how to choose between H8 and H9. Now, among the last, one of the last is also the super hyper soft set, again based on extension of hyper soft set and super hyper algebraic structures where we work on power sets of power sets. We say n power set of a power set of a power set, and so on, depending on the problem we have. And according to this and similar to this, a superhyper algebra, superhyper graph, superhyper topology, and in general, any superhyper structure. Super stands for the power sets. So instead of the attributes A1, A2, AN, we have the power set of A1, power set of A1, A2, AN. So therefore, a superhyper subset it's a function defined from the power set of the first set of attributes, power set of times power set of the second set of attributes, and so on, power set of the nth set of attributes. So this multiplication means here Cartesian product. So let's see a real example, because all these new types of subsets resulted from our everyday life and are caused by indeterminacy and not clear information that we have to deal with in our everyday life. So we define the function f from the power set of A1 times the power set of A2 times power set of A3 times the power set of A4 with values in the power set of U. So this is a superhyper subset. And then the example, let's see as example, we consider it as before, f of medium tall. So this will be the power, an element of the power set of PA1. And white, red, black, so they are all together, meaning an element of PA2. And then female, American, Italian, so will be the female, and then P3, and then P4, American, Italian, therefore nationality, is equal to X1, X2, which means the following. F of medium or tall and white or red or black and female and American or Italian is equal X1 or X2. So therefore, the elements or persons X1 and X2. But here we have a larger variety of selections. So X1 and X2 may be either medium or tall, but not small, either white or red or black, but not yellow. So here, see number 2, mandatory female, so not male, this one, number 3, and either American or Italian, but not French, Spanish, Chinese. So according to the other one. So we have a multiple of alternatives for such kind of superhyper subset. So that's why it's a little more difficult to work with this one, but this occurs in our everyday life. Now, tree subset is inspired from the tree graph. The tree graph, so if we consider a universe of discourse U and H a non-empty set of U, P of H the power set of U as before, let A be a set of attributes, which may be parameters, factors, and so on. And A is formed by subsets of specific attributes A1, A2, AN. We have the following. So A1, the set of attributes A1 may be formed by sub-attributes A11, A12, and so on. Similarly, the set of attributes A2 formed by sub-attributes, and so on. AN, the set of attributes which is formed by some sub-attributes. Therefore, the above A, I, J are sub-attributes of attributes of second level or attributes of second levels. So A1, A2, AN are attributes of first level. And if we have two indexes, we have attributes of second levels. If further on we go to more levels, would be A, I, J, K attributes of level 3. So we have attributes, sub-attributes, then sub-attributes, then sub-attributes. So we can refine it in as many as necessarily. So a function defined by the power set of the tree generated by the original set of attributes A to the power set of H. And in this case, all node sets of the attributes of level M have this shape here, AI1, where I1 can be 1, 2, and so on. So let's better see an example practical example of tree subset of level 3. So we have the attributes that which will be node 0. Then here, the attributes is formed by two main sub attributes, so size and location, and then the size also by sub attributes, small and big. Location by two, it's formed also by two sub attributes, Arizona and California, and then these are also formed by sub attributes of them. Arizona has the cities Phoenix and Tucson. So this is actually a classical tree in graph theory, but we use it now in a subset. So level 0 is the node attributes, level 1 is the size, location. So this is level 0 attributes, level 1 size, location, level 2 small, big, Arizona, California, and level 3 Phoenix, Tucson. So we have actually 3 levels. And let's consider again a set of houses, H1, H2, H10, be a set of houses, and then P of H, the power set of H. Then the set of attributes, A is formed by A1 and A2. So we explained before, A1 size, A2 location. Now A1, the size, is formed by A11, A12, meaning size is small, big. A2 location is formed by A21, A22, meaning Arizona, California, as American states. And then further on, A22, it's formed by A211, A212, which Phoenix and Tucson were Arizonian states. So we may consider f of big Arizona Phoenix is equal to H9, H10, meaning f of big houses from the state of Arizona, actually from the city Phoenix, H1 and H10. Same thing here, similar here. F of big state Arizona, big houses in a state of Arizona, city of Tucson, are H1, H2, H3, and H4. And this is the way we use a tree in order to define a tree subset. Now you have this website, https ://fs.unm.edu tss / which is the site about the new types of subsets that I have introduced starting from 2018 to 2023, the last one. Actually, you have also information and links to some more information about the subsets, the new subsets introduced. And we have also defined new types of subsets. We have defined some algebraic indeterminate algebra that we can find and then you can use. So you can go to this website and click on links to see more types. For example, let's see this one, see indeterminate subset here, published in a set, nutrosophic sets and systems, and then information about them, and some of them are reproduced herein. So you're welcome to contribute papers